Hello students, in today's video we are going to work on finding the limits using factoring. So we're going to start with this quick warm-up. This would be a good time for you to pause your screen and try this problem on your own. Hopefully you've paused your screen and you're coming back to check the answer. In the recent days, all we've been doing to find the limits is substituting this limit value in. So in this case, as x approaches 1, we would typically substitute that in. Now if we did that in this particular case, we would get 1 squared minus 1 all divided by 1 minus 1. And unfortunately, that would give us an answer that was undefined. So obviously that's not going to work for us. The next option that we have is to actually factor it. So if we take a look at this problem, we get x plus 1 times x minus 1, because it's the difference of two squares, all divided by x minus 1. And when we simplify this, the x minus 1's cancel out, and we're left with the limit as x approaches 1 for x plus 1. And this time, when we substitute the 1 in there, we get 1 plus 1, which is 2. So the limit as x approaches 1 for that function is actually 2. So keep in mind, our first attempt is to substitute that value in to see if that'll work out nicely. If it doesn't, if it gives us something that's undefined, then you're going to want to go ahead and factor, cancel, and then resubstitute it. Now here's how this works. If we take a look at the graph itself and graph that again, we had that function x plus 1 we had x plus 1 times quantity x minus 1 all divided by x minus 1, sorry. Now what this looks like, especially once we cancel this out, you're left with that function x plus 1. Now, x plus 1 is a diagonal line that looks like the following. Now you'll notice because we canceled out that x minus 1, that's going to give us a whole. So what that does is at x equal to 1, so if we solve that x minus 1 equal to 0, we get x equals 1. That means at that value for 1, we get a whole. So at this particular spot, we have a whole. So it's a continuous line, continuous line, continuous line, and then once we get to that one, there's a hole, and then it continues on. So you'll notice, other than my diagonal line or my not so straight line, is that this line is straight. However, there is a hole. Let me adjust this because this line should be higher. There is a hole where x equals 1. And that's the point where that graph is not continuous. However, it does have a limit. So let's look at the next slide. So in order for us to solve these functions, and to find these limits rather, we are going to have to start factoring. So first, if the denominator has a limit is 0, or if the denominator of a limit is 0, try factoring the top and bottom, then cancel common factors, then substitute to find that limit. So let's look at a couple example problems. So in example 4, if we substituted the 3 on the denominator, we'd get 3 minus 3, which is 0, therefore undefined. So what we're going to do first here is we are going to factor. So again, we have a difference of two squares. So we have x plus 3 times quantity x minus 3, all divided by x minus 3. Our x minus 3's will cancel out, and we are left with the limit as x approaches 3 for the function x plus 3. Now when we substitute 3 in there this time, we get 3 plus 3, which is equal to 6. Therefore, the limit as x approaches 3 for that function is 6. Let's try one more time. In this U-try, this would be a great time for you to pause the screen and try it on your own. Hopefully you pause the screen and you're coming back to check your answers. So again, If we substitute that 3 into the denominator, you'll notice that we get an error and it's undefined. So we're going to want to factor. We factor the numerator and we get 4 times the quantity x minus 3, all divided by x minus 3. And again, these cancel out. You're left with the limit as x approaches 3 for the function 4. Now you'll notice here, we can't exactly substitute the 3 in because there's no variable. But because we do have an answer, or because we do have a value, you'll find that the limit as x approaches 3 for 4 is just 4. So that's all for this video. Please have questions ready if you're not sure, if you don't understand some of this, because we're going to have a lot of time in class to practice this. That's all for now. I'll see you guys next time.